Who's ready to learn how to derive an equation to figure out the area of a surface of revolution? Well, I need 50% attendance to pass my teacher evaluation. To begin, we start with the Frustrum formula, which is pi r1 plus r2. And then we also start with the length of a curve formula, which is giant square root delta x to the k squared plus f of x to the k minus f of x to the k minus 1 squared.
But Mr. Schichtel, what's a frustrum?
Well, it's just getting to that, Vinny. You see, when a polygonal path is revolved around the x-axis, it generates a surface of n parts, each of which is a portion of a right circular cone called a frustrum.
Oh, now I understand, Mr. Schichtel.
The length of a curve into the frustrum formula, so we get s of k equals pi f of x minus 1 plus f of xk times the square root of delta x squared plus f of xk minus f of x to the k minus 1 squared. So to save space, I'm moving the one formula up to the top, that way we can have more working space. And we're going to add these areas to get an approximation of S of area on the surface. So we can approximate S to be the limit of n from k equals 1 for pi f of xk minus 1 plus f of xk times the formula for the length of a curve, which is the giant square root delta xk squared plus f of xk minus f of xk minus 1 squared. And then we put that in the Riemann sum formula and apply a mean value theorem, and we get f of xk minus f of kx minus 1 over xk minus 1 equals f prime. How much time do I have left, class?
30 seconds.
Well, x asterisk k or f x to the k or f x to the k minus f x k minus 1 equals f prime x to the kx asterisk times delta x to the k. Goodbye, class. Welcome back to class, guys. This is where we left off. We last applied mean value theorem. What we're going to do now is simplify this equation. So we now know S is approximately n as k equals 1 from pi f of xk minus 1 plus f of x to the k, and then giant square root delta x squared plus f prime x asterisk k squared delta x to the k. And then you can even more simplify down to n as k equals 1 pi f of x to the k minus 1 plus f of x to the k, and the giant square root 1 plus f prime x star k squared delta x to the k. Well, to make more space, I'm going to put that last step up to the top. And because it's not yet a Riemann sum, because it involves x to the k minus 1 and xk, so to eliminate, we observe the average value of numbers f to the xk minus 1 and f to the xk. lies between that number, so due to the intermediate value theorem, we know there is a part where 1/2 f to the xk minus 1 plus f to the xk equals f to the k double asterisk, which represents this formula as s approximately n the k equals 1 2 pi f xk double asterisk, then giant square root 1 plus f prime x asterisk k squared delta xk. And then you put it into a limit. S equals limit of max delta x h goes to 0 and equals 1 2 pi f x double asterisk k giant square root 1 plus f prime x asterisk k squared. So we put into a limit equals limit as max delta xh goes to 0 from n k equals 1 2 pi f x double asterisk k giant square root 1 plus f prime xk asterisk squared delta k asterisk, in which we can rewrite as s equals integral from a to b to pi f of x 1 plus f prime x squared dx. And then if you simplify this even farther, you can get s equals integral from a to b to pi f of x giant square root 1 plus f prime x squared dx. And then this can also be rewritten as s equals integral from a to b to pi y 1 plus dy dx squared dx. And so it's your choice of preference which one to use. Any questions?